we're going to take a look now at the Pythagorean identities. And these come from the idea of the unit circle. And we see in the diagram here that if we have an angle theta, and we take the triangle formed by that angle, we know that the coordinates of that point on the circle are cosine of theta, sine of theta. Well, that means that the length of the horizontal side is the cosine of theta, and the other side is the sine of theta. So from that, we can find the length of the hypotenuse. But because this is the unit circle, we know the length of the hypotenuse is 1. So that gives us the first of the Pythagorean identities, that sine squared of theta plus cosine squared of theta equals 1 squared, or 1. So this is a very important trigonometric identity, and we can take that and kind of change its form around a little bit to get some other related identities. First of all, we see that if we take this original and divide, I'm sorry, not dividing yet, but just subtract the sine squared, we get that cosine squared of theta is 1 minus sine squared of theta. Likewise, we could subtract the cosine and get sine squared of theta is 1 minus cosine squared of theta. So those are just some very minor changes to the identity to get to those versions of them. Now, a little more, if we take that identity, rewrite it, okay, sine squared theta plus cosine squared theta equals 1. If we divide that on each side by sine squared theta. So we've got to divide everything by sine squared theta. Gives us a totally new identity, because sine squared theta over sine squared theta is 1 plus cosine squared theta over sine squared theta, which is cotangent squared theta, equals 1 over sine squared, which is cosecant squared of theta. So that gives us another Pythagorean identity dealing with cotangent and cosecant. Likewise, if we take that and divide the original, sine squared theta plus cosine squared theta equals 1. Divide everything this time by cosine squared. This then yields sine squared over cosine squared, which is tangent squared of theta, plus cosine squared theta over cosine squared theta, 1, equals 1 over cosine squared, which is secant squared of theta. So, by knowing the one basic Pythagorean identity, sine squared theta plus cosine squared theta, we can very quickly develop the formula for the relationship between cotangent squared and cosecant squared, and tangent squared and secant squared. And by adding and subtracting from one side or the other, we can get other forms of that also. If we're given then, as in this example, that cotangent of theta equals 2, cosine of theta is less than 0, we want to find the sine of theta and the cosine of theta. Well, if we start with the identity involving the cotangent squared of theta, we know that rewriting the identity to help us memorize it and to help us work through, 1 plus cotangent squared theta equals cosecant squared theta. Well, we know the cotangent is 2, so that's 1 plus 2 squared equals cosecant squared of theta, or cosecant squared of theta is 1 plus 4, or 5. Well, if cosecant is 5, then we can use that to find the value for the sine of theta. Since cosecant squared is 5, that means that 5 is equal to 1 over sine squared of theta, or sine squared of theta is 1/5. Taking the square root, we get that the sine of theta is 1 over the square root of 5, which is, of course, the square root of 5 over 5. So now we have the sine and the cotangent that we were given. To find cosine, we can now go to our original Pythagorean identity, that the sine squared of theta plus the cosine squared of theta is equal to 1. Since sine is 1 over square root of 5 sine squared, back to that 1/5, plus cosine squared of theta is 1. And if we subtract the 1/5 from each side, we have cosine squared of theta equals 1 minus 1/5, or 4/5. Taking the square root, cosine of theta is 2 over the square root of 5, or 2 square root of 5 over 5. Take a minute now to try the next problem on your own. Using the identities, you should have found that the values that we were looking for were C, that cosecant theta is 5/4, cotangent of theta 3/4.